Hey everyone, today we are going to be talking about the new ONNX Runtime release, version 1.12, and I'm going to be joined by some guests from the ONNX Runtime team. We're going to talk about everything that was released, and then we're going to deep dive into 4 exciting features with the developers that built them. Let's take a look. All right, and now I am joined by Faith. Faith, why don't you tell us who you are?
Hi, thanks for having me. So I'm Faith. I'm a PM working on ONNX Runtime. So today I'll just cover a bit of an overview of the 1.12 release and some of the new things we're adding. And we'll also be going deep in depth with a couple of the engineers on specific features that were added, but we'll start with the overview here.
Fantastic.
So general announcements, one update that we've made for anyone who is building an execution provider or maintaining one, we have now expose the lightweight compile API as a default compiler for execution providers. So previously this was only available for the mobile builds. So this is just a heads up that if you are developing an AP and using the legacy compiler API, you'll have the course of this release to update before we fully deprecate it in the next release. Another update is that we are deprecating .NET Standard 1.1 support, and we're removing it for the upcoming release. And we'll talk a little bit more later on about the .NET support. In terms of key updates, generally we do try to keep up to date with the ONNX spec, and ONNX 1.12 was released in the last couple months. And so ORT is now updated to include support for ONNX opset 17, as well as ONNX ML opset 3. One new feature we added was the capability to invoke individual ops without the need to create a separate graph. So this is useful for anyone who wants to use who is building custom operators, but doesn't want to reuse one of the existing ORT kernels. And one of our devs, Randy, will be talking more in depth about this feature. We do work often with large models across Microsoft and some of the different products groups that we work with, and we are adding features to support that. So in this release, we are adding support for feeding external initializers for inferencing. And we're also added a build switch to disable the Epsil library, just to remove a dependency for anyone who has issues with getting approvals for these types of dependencies. In terms of packages, we've added support for Python 3.10, and we've also enabled the Mac M1 support in the Python and Java libraries. Previously, these were already available in the NuGet packages, but we saw a lot of community interest for Python and Java, and that's now available. And we've also added .NET 6 MAUI support in the C# package, and our engineer Scott will be talking more about this. And also, as part of a couple months ago, Intel started publishing ONNX Runtime OpenVINO packages that are pre-built so that you don't need to be building these from source anymore. And there's an update of this for on ORT 1.12. On performance and quantization, we're continuing to work on improving performance with each release, primarily driven by concrete use cases and models that we see being used across Microsoft products. So with this release, like other ones, you'll see optimizations for specific kernels. And we've also been continuing to work on the quantized kernels as well for use cases where quantization is useful to decrease memory size. On execution providers, we are continuing to keep up to date with the latest libraries from TensorRT, OpenVINO, DirectML by updating to the latest versions that have been released. And we'll talk a little bit more about this later. One new update is that TVM EP has now improved documentation on how to use this, and you can read about the details of this at the link. And another new EP that we are introducing with this release is for Qualcomm SNPE. And we'll touch a little bit more on this later as well. We've also added the general infrastructure for the XNNPACK EP. So this is not quite ready to be used right now since we only support a couple of operators, but the basic infrastructure has been added as part of this release. And we have ongoing work to add more kernels to actually make this useful for mobile and web scenarios. On ORT mobile and web, both of these are primarily driven by use cases that we see with the Microsoft products, and we're continuing to work on adding new operators and reducing binary size and to make it a feasible option for those devices with more constraints. So yeah. And the last thing I want to touch on is ORT training. So overall, most of the updates that we've provided with these releases is primarily focused on inferencing. But I do want to mention that we are continuing to invest in ORT training for accelerating training of large models. And most recently, we've integrated with Hugging Face Optimum to accelerate several of the Hugging Face models. So this is available to try out now and used as ORT training kind of under the hood, in addition to some other optimizations that they've added. So that is, those are some updates on training for this release.
Great. And I think that's all of the release notes. Thanks for that fantastic overview of what's coming out. Now, if you want more details, stick around because we will be talking to the devs that have been working on some of these features. Thanks so much. Next up, I am joined by Randy. Randy worked on a really neat feature that I'm excited to talk about how to use native ONNX Runtime Ops in custom ops. Randy, why don't you tell us a little bit about who you are?
Hi. Hello, everyone. So my name is Randy. It's nice talking to you here, and I'm the software engineer that are working on the ONNX Runtime Core, and mostly focusing on the threading, memory, and the core framework. So yes, we have this wonderful feature, and I cannot wait to just talk about details about it.
And you had an extra role in this release called the release manager. So thank you so much for all your extra effort in getting this out. Can you tell us a little bit about what the release manager role is in ONNX Runtime?
Yes. Basically, the release manager has to just organize every piece of the ONNX Runtime. Basically, there's just many features, right? And you have to select a proper time when you want to cut the release from the master branch, right? That is already starting point. And after that, you have to just build the entire release branch according to the different packages we want to release and test the package. So along the way, there may be other changes into the master that made by the feature owners as a fix or even further enhancements, right? You have to track all the changes in the master as well to make sure that if there's a feature it wants to be released in the release branch, it will be included. So we call it a cherry pick. So before the final release, there will be many rounds of cherry picks. And during each round, you have to make sure that the change doesn't break anything. The pipeline's going still running very fine, and so the function test should be all passing, and there's no surprises. So, but the thing is, there will be some surprises, such as maybe some features may break a big test in the release pipeline. You have to just define the scope of that feature, locate the person to talk to, and work with them to just deliver a fix, and everything goes over again. And so the thing is that you have the entire support from the team. And still, you have to just track many threads on your own and make sure that the final release is the one that you want to release. So basically, that is it.
Yeah, there's always surprises during release time, isn't there? It's not, I think with every product, everyone has been through that with the releases. So thanks so much for getting this out. So now let's talk a little bit about this feature that you worked on. How did this feature come about?
Yes, so this feature, we heard the request maybe half a year ago. So before that, everyone knows that if you're familiar with ONNX Runtime and you're familiar with how to use it, you will know that we have a feature that is called the custom op. Basically, that is that you can develop your own customized operators and embed it to the ONNX Runtime to do your computation on your own graph, right? So that is ongoing for a while, and it works perfectly, and it is, however, very popular among the users of ONNX Runtime. And maybe I think half a year ago that we heard some customer saying that they have a case that they have a custom operator that, and it works perfectly, but to make it even more performant and versatile, they want to just do some matrix computation within the function body. So but to do that, they don't want to just code another entire full working solution, but they want to consume the one that is already the part of the ONNX Runtime. Right. So as it is known to all, that ONNX Runtime has a very powerful implementation of the matrix computation on CPU, right? And we have spent so much time to make it very, very powerful. So customer just want to try to utilize that function, particular function in their own custom op. But the case that with what we have as a half year ago, there's no easy way to achieve that. So what the customer did is that they just copy the function into their own, copy the native function from the ONNX runtime into their own custom operator function, and which cost them a huge amount of efforts to just develop and maintain, because the function is kind of intertwined with other built-in functions in the ONNX runtime. So they came to us, say that, okay, I really love your matrix computation function. So I'm in the operator. So they're saying that can I just try to somehow to reuse the function, but in a much easier way. So after discussion and some prototyping, we finally found the case that we can open this feature. Propose this feature that we can allow the customer to call directly into a native ONNX runtime operator, without building a graph or something alike. So basically, that what happens will be that with a feature in the custom op, they can just by a few simple steps, they can just call into this native ONNX runtime op of the matrix computation. So which means that in the future, with the help of this feature, they don't have to copy any code. They just do some preparation and get the function and just execute it and expect the results. And just a couple of lines code compared with the past, they have to copy a few files. So basically, that is a very first reason why we are giving this feature. Thank you.
Yeah, that's awesome. So you can leverage the existing ops that exist in ONNX runtime in your custom ops simply in a way to get the like performance and customization that you need for your specific business needs. So that's super important. Really cool. Was there any other reasons that we thought this feature was important, or that the feature was created?
Yes, there's indeed another reason that we want to propose this feature to the community. And also in the few months back, that there are another group of customers. They are working on audio processing, right? They're processing audio frames one by one. Basically, they just call ONNX runtime on each frame they have, right? So as known to all, for frame processing, that they always want to do some statement management, meaning that they may want to just cache some past inputs or outputs and combine them with the latest input as a new aggregated input into the model. So in the past, there's no easy way to achieve that, because suppose that they are calling into a convolution operator of the ONNX runtime, right? So we have no easy way for them to achieve the goal that, okay, they can cache some outputs of this particular operator and feed the output as a next input into the next frame inferencing. So they also came to us regarding their case, say that, okay, so suppose they want to do some special processing on this convolution operator, that is, they want to combine some past outputs of this particular op with the current input and feed the operator with a combined altered inputs. So how to achieve that? But so we approach them with this feature as well, because with this feature, so suppose that they have a convolution operator in the original graph, and it works perfectly. What they can do is that they can just wrap it up with some kind of a custom convolution operator, and in the middle of the operator, they can just call into the native convolution operator of ONNX runtime. But before that, they can do some pre-processing of the inputs, and after the calling, they can cache up the outputs, meaning that they can use it. They will have a chance to use it in the future inferencing. So basically, by the feature, we allow them to add a wrapper around the native operator of ONNX runtime to do the statement management. And due to their case, due to some thanks to some prototyping, they came to us saying that, okay, this feature completely just make their life easier and achieve the purpose. So basically, that is another reason why we are giving out this feature.
That's great. It's great to see that flexibility, and I'm sure those are just two use cases of many use cases where people will find ways to implement this. Is there any samples available, or anywhere we can direct people that want to take a look at how to use this?
Indeed, we have documented the feature, and we have samples provided in the community website. So later I can just paste the link to the sample. I think anyone that is familiar with ONNX Runtime can learn to use the feature in a minute.
Fantastic. Thank you so much for hanging out with us and for being the release manager on this release and for providing some insight onto this new exciting feature.
Thank you.
All right, next up we have Scott. Scott, why don't you tell us a little bit about yourself?
Hi, Cassie. My name's Scott McKay. I am the lead for ONNX Runtime Mobile. I've been working on ONNX Runtime for a few years now and working on ONNX Runtime Mobile since it was first created.
Wow. Awesome. So in this release, what did you work on? What's new in this version of ONNX Runtime?
So we have a few different areas that we worked on in the release. Those are kind of spelled out in the release notes. One big area is we added support for .NET 6 and in particular for MAUI applications in this release. And
what is MAUI and well, .NET 6 is the newer version. There's lots of cool things. I think most .NET people probably know about that. But what is MAUI? Because that's kind of a new thing.
Yeah, so .NET 6 was about unifying all the different parts, all the different ways you could build an app using the .NET frameworks. And so MAUI is kind of the evolution, you could call it, of Xamarin Forms. So previously Xamarin was targeted at mobile platforms, so Android and iOS. With .NET 6 MAUI, because things have been unified, you can now build a MAUI app that targets desktop as well as mobile. So with one single shared code base, you can build an app that can run on Android, iOS, macOS, and Windows, and I think Linux as well, from a single shared code base. So there'll obviously be some platform-specific code in there, but the bulk of it will be shared, which is a great advantage for a developer who wants to create something that runs essentially everywhere.
What are the new platforms that ORT is supporting?
Okay, so previously we had Xamarin support. So we supported target frameworks for iOS and for Android via Xamarin. With this release, we're adding additional .NET 6 targets. So those include the base .NET 6 framework, as well as Android, iOS, and macOS targets. So that should let you create an app and use ONNX Runtime on all those different platforms. It will plug in the correct native library to use ONNX Runtime for that efficient execution of your AI model, as well as platform-specific things.
Awesome. And is that then going to be able to leverage whatever execution provider is on those different platforms, right, in order to?
Yeah, so for example, with Android, we include the execution provider for NNAPI, and on iOS, we include the execution provider for Core ML. Those will let you use the NPU, or the neural processing unit, on your mobile device. So if your model can be executed using that, you might get benefits in terms of model execution speed, or you might get benefits in terms of efficiency. So you could run the model and use less power. So if you've got a scenario where you're going to maybe process a video stream or something where you're going to do a lot of work, but you don't want to drain the user's battery, that can provide benefits there.
Absolutely. And from a code implementation perspective, am I using the exact same code for all of these different ones for ONNX Runtime, or do I switch my target, or is there any sort of like different code changes that I need to make, or does it just kind of figure that out for itself?
It'll figure most of it out for itself. We have C# bindings for ONNX Runtime, so you're going to be using, like, your interaction with the ONNX Runtime library is going to be consistent across these different frameworks. So obviously you will have some platform-specific code in places, like there's different device screen sizes. You might have some different logic about how you manage layout and that kind of UI side of things. But from the perspective of how do you use ONNX Runtime on these different platforms, it will just be the same code will run and do the same thing on all the different platforms. With executing the model, there might be different pre-processing. So for example, on Windows, getting the image might look slightly different to getting the image on Android or iOS, but that will depend on the C# libraries that you can leverage to do those kind of operations.
How do I add the usage of ORT into my .NET 6 project?
So we have there's a few different ONNX Runtime NuGet packages. There are two in particular that you'll want to use. One is the Microsoft.ml.ONNX Runtime. That contains all the native libraries, which is a C++ implementation for executing the model. And that will also bring in the Microsoft.ml.ONNX Runtime.manage, which is the C# bindings, which will give you the nice C# way to interact with the native library.
So pretty standard for most C#
It
projects?
could be the only trick is don't get confused. There's also like a GPU library, which is CUDA specific for Windows. So the two libraries I mentioned are the general purpose, will run pretty much everywhere libraries.
So it sounds like there is a lot of great things coming out and a lot of things that are going to make it easier. How do we learn to do this? Are there any examples that you could provide?
So right now we do have a GitHub repo that has an example Xamarin app. We'll be updating that in the next week or so to add a MAUI app, but it's going to look really, really similar. Like the difference is going to be essentially in the target frameworks that are used. The MAUI code is going to be slightly different, but to get an idea of what the code involved is, you can look at that Xamarin sample, and we'll put a link somewhere in this video. And yeah, we'll add the MAUI one in the next week or so, and that will show you an example app that can run on mobile as well as desktop.
I think we're going to have to invite you back to do more of a deep dive tutorial on this new MAUI support, because I think it's super interesting and will be super useful. And it'd be great to see like the demos of these features that we are releasing.
Yeah, for sure.
Well, thank you so much for joining me and talking about the cool features that you added as part of the release. Thanks.
Okay, awesome. Thanks for inviting me, Cassie.
All right, next up we have George. George is going to talk to us about execution providers. Why don't you tell us a little bit about who you are?
Hey everyone, my name is George. I'm one of the dev managers on the ONNX Runtime team. And as you know, ONNX Runtime was built with extensibility in mind. And one of the core design principles is that we can integrate with other hardware. So the execution provider interface is our way to do that. So, you know, we work with all the major hardware vendors out there, and to integrate their hardware via, you know, the execution provider interface. And my team specifically works with a few of those vendors, and we focus on inferencing workloads. And
awesome.
Yeah.
Great. So can you tell me a little bit about what was updated with the execution providers for this release?
Sure. So my team primarily works with three vendors, NVIDIA, Intel, and Qualcomm. And for the NVIDIA side, we leverage their inferencing engine called TensorRT. So we integrate TensorRT support into ONNX Runtime, and we now have the latest and greatest support for their TensorRT 8.4, which was just released. Also, we did a bunch of refactoring and performance optimizations on our side. I can give a couple examples. Like one example is we added an option to share execution context memory. So if you have a bunch of, let's say you have an ONNX model and that model isn't fully supported by TensorRT, we're going to partition it and we'll dole out kind of the subgraphs that TensorRT can support. The problem is if you have too many of these subgraphs, then the memory consumption overhead can be significant, right? Because for each subgraph, you have to allocate memory for an execution context. But now we kind of leverage some APIs that they provide to share that context memory, and that will reduce the memory overhead. Another cool kind of optimization or refactoring we've been doing is related to our engine caching support. So basically, engine cache is TensorRT's, or TensorRT engines are kind of execution plans for TensorRT. And to build these execution plans, it can potentially take a long time, like because at runtime it's doing some profile-based optimizations, and depending on the size of the model, that can take a while. And you may have to rebuild, or ONNX Runtime may have to rebuild the engine at inference time if the input shape changes and the existing input shape range that we're covering doesn't cover that input shape. We have to rebuild the engine, and that could take a long time. So if you enable the engine caching, you can pre-build it, you know, ahead of time, and then at runtime it's built, and you don't have to build it at runtime. So we did some refactoring around there to make it more efficient to serialize and deserialize these engines.
Great. Those sound like some great optimizations to improve speed and get the performance people are looking for. So another one I know you said there was some, or I read that there was some updates on was Snappy. Can you tell me what Snappy stands for?
Oh, cool. Yeah. Snappy is a really cool one that I'm really excited about. So Snappy is from Qualcomm, and Snappy stands for Snapdragon Neural Processing Engine. So it's Qualcomm's runtime for accelerating AI workloads on their mobile Snapdragon SoCs. So these are powering mainly devices of mobile form factor. Like for example, the Surface X devices, they're tablets, right? They're powered by Snapdragon devices, and of course, many different smartphones out there running Android and such are running on Snapdragon. So we're really excited. This was open source. This execution provider was open sourced alongside the announcement of the Project Volterra at the last month's Microsoft Build conference. So it's really awesome that we're expanding our hardware ecosystem and supporting these mobile devices. Whereas ONNX Runtime traditionally or initially kind of started off on cloud and server workloads.
So this is brand new, right? The Snappy support with this release?
Yeah, I mean it's been in the works for a while internally, but we found that we saw a good opportunity to announce it's a wide availability at the Build conference alongside with Qualcomm.
That's awesome. And so if people didn't hear about Project Volterra at Build, can you just give a quick kind of summary of what that is?
Oh yeah, sure. So Project Volterra is kind of a dev kit that Microsoft is making so to allow developers to target to build out apps with AI capabilities on a kind of very slim profile. It looks like a small little cube or box. It's pretty nice looking. So that developers can start writing apps that take advantage of the NPU that's on these dev kits, right?
Cool. Those sound like some really great updates to help support more diverse hardware, which is one of the great benefits of ONNX Runtime, right? Is being able to support all of the different types of hardware. The other update we had was with OpenVINO. You want to tell me what we updated with OpenVINO this time?
Oh yeah, cool. So on the OpenVINO side, we work closely with Intel, and they help us implement the execution provider. And for this release, they were able to enable some better support for models with dynamic input shapes. So previously, this was supported. It worked okay, but with this new feature, we saw very good performance gains. Like, don't remember off the top of my head. I think we can share some results. They're probably in the 20-30% range, I think.
Of improvements?
Yeah. For models with dynamic inputs. Because previously you would have to recreate the execution context each time, and now it can support a range of input shapes.
Fantastic. Now, I know that it used to take a lot of steps to use OpenVINO with ONNX Runtime. I think you said there were some improvements with that as well, right?
Oh, yeah, definitely. That's a good thing to call out as well. So Intel has started building Python packages that are being hosted on PyPy with ONNX Runtime with OpenVINO enabled, right? So previously, as you mentioned, it was really difficult for a developer to set this up before. Like they would have to build ONNX Runtime from source, enable OpenVINO. They would have to install all the OpenVINO dependencies themselves. Now it's like, if you go to our onnxruntime.ai page and select OpenVINO, the instructions are now pip install ONNX Runtime-OpenVINO, and it'll pull in it'll pull in the OpenVINO dependencies. You don't have to install it and figure out how to install it.
Those are some great updates. Wow, lots of really cool stuff coming out in this release for execution providers. Any documentation, examples, or anything else you want to share about the updates with this version?
Yeah, we'll have links in the release notes to some documentation. Well, we always update the documentation every release. We do have some new example notebooks that are going to come online for OpenVINO pretty soon. That's hosted in our other repository, the inference examples repository, which we can also link to in our release notes.
Yep, I'll add the links in the description as well for this video.
Cool.
Well, thanks so much for joining us and telling us more about the exciting updates that came out for execution providers with this version of ORT.
Great. Thanks for having me.
Next up, I am joined by Dmitiri. Dmitiri is going to be talking to us about some of the performance improvements we made for this release. Dmitiri, why don't you tell us a little bit about yourself?
Hi, my name is Dmitiri Smirnov. I'm a principal software engineer here at ONNX Runtime at Microsoft. I've been working on the project here at Microsoft for the past 2 years, responsible mostly for the core infrastructure, but working on really anything that came my way throughout the project, starting with introducing the new ONNX kernels to the standard, implementing them. I looked also at the ways to improve the infrastructure, coding standards, and increasing the development velocity.
I know there were some improvements to the CPU performance. What prompted these improvements?
Well, for this release, I've been focusing on the performance of certain aspects of the product. So why are we doing this is really a timely question. Typically, customers that focus on performance would utilize GPUs or some other performance accelerators.
Mm-hmm.
But this time around, several customers approached us and told us that they want latency to be lower 2 times, small variance on the latency. They want it to be on CPU, and they also wanted a low CPU usage. So naturally, that came as a challenge.
Great. So they were looking for a little bit more speed improvement for their CPU processes in order to kind of meet their latency needs. Can you tell me a little bit about how these improvements were implemented?
Well, first and foremost, we needed to get rid of memory allocations during inferencing, or reduce them as much as possible, as it did have negative effect on the latency distribution. ONNX Runtime makes use of a C++ standard library. Asking us not to allocate memory is a very challenging request. That required some refactoring and changes in the way we write code. We also made sure that we do not acquire locks where not necessary. Our product is stateless by design. However, we did have a couple of places where things could be improved. The work is not finished by any means. You're going to see more changes in this release and in the future releases. We're going to look at cache locality and question the performance of our current memory allocators. Our thread pool improvements are an ongoing work in progress as well. And the more we improve, the more smaller changes come to our attention. We also want to utilize the thread pool in more places. I'm happy to say that for some scenarios, we reduced our latency by a factor of 2, and in some other scenarios, even more so.
Well, that's good news for those people out there doing CPU inferencing with ONNX Runtime to see that we've almost doubled in some scenarios the performance. Anything else you want to share? Any resources or anything? Were there any code changes that would happen for how they implement it, or is it all kind of behind the scenes changes that they're just going to get a nice surprise that they might have better performance?
Some of them are, most of them are behind the scenes, but we also made some changes in the API, make sure that it's more modern, it doesn't leak memory, and it's more convenient to use, specifically when we return pointers to the allocated memory. We want to make sure they are not dangling. Our previous API had some shortcomings that we corrected in this release.
Thanks so much for hanging out and telling us a little bit more about the performance improvements.
My pleasure, Cassie.
Thank you so much for my guests that came and talked about the cool things that they're building. As always, if you want to read more about the ONNX Runtime release, go ahead and head over to our GitHub, where you can find the full release notes there. And I will also provide that link in the description. Let us know what you think. Let us know if you have questions. We'd love to hear from you. Thanks for hanging out.